All right, hello students. Today we're moving on to lesson 1, the relationship of adding and subtracting. So we're going to talk about how addition and subtraction are related to each other with some things you hopefully remembered from elementary school, just kind of get us started with this new module. So here we go. Opening exercise. It says draw a tape diagram that represents the following expression. So how can we draw a tape diagram that represents 5 plus 4? So I have a little tape started over here. I'm going to use this to kind of make it go a little faster. So, of course, now we need to start with 5 of these. So I'm going to make 5 copies. One, oops, 1, 2, 3, 4, 5. So let's go ahead and kind of set up our 5. 1, 2. I'm going to just try to do this a little quick. Might not look perfect, but it should look pretty good. 2, 3. Let's go ahead and go with 4. And then, of course, that's 5. Okay, so of course this part right here represents the first part of the plus 5. So let's go ahead and kind of just draw this right here. This right here represents 5. Now, of course, we're going to add 4. So all I got to do is just simply add 4 to it. I made that a little bit long, so let's go ahead and erase that portion right there. So now I need to make 4 more of these. So let's go ahead and copy and then paste 1, 2, 3, 4. So I'm going to add 4 to this. So let's go ahead and try to line those up. So there's 1, there's 2. All right, there's 3, there's 4. All right, so there you go. So that's me adding the 4 to it. So I'm going to take a different color. And so of course from here to here is the addition of 4. And so of course all together we could add this up, and of course all together we see the representation of 9 boxes. So of course 5 plus 4 of course equals the top portion of 9, because there's 9 boxes here all together. All right, so we look at B here. If we kind of continue to go, it says write an expression for each tape diagram. So kind of writing, what does this represent? So kind of like the 5 plus 4. Well, so let's go ahead and kind of look at this. So of course here there's 2 boxes, so this is 2. And this is adding because the boxes aren't going away. They're adding boxes to it. So it'd be an addition of 2. So 2 plus 2. That's an expression. An expression does not have an equal sign, so we don't want to put equals 4. Otherwise, it would find the value. We're just simply asked to write an expression. So there we go. Come down to the double I or the 2. If we look here, if we're writing another expression that looks similar to this and the one above it, there's 1, 2, 3 on this kind of section. So that's 3. Once again, nothing's going away. We're adding to it. We're adding 1, 2, 3, 4 boxes. So here's our expression. Our expression is 3 plus 4. All right, so that's kind of the introduction to the lesson. Go ahead and stop the video and go ahead and move on to the next one. All right, hello students. Welcome back. Let's go over some exercises together. So let's look at exercise 1. It says predict what would happen when a tape diagram, has a large number of squares. Some squares are removed, and then the same amount of squares are added back. So what do you think is going to happen? If I have a bunch of squares, I take some away, and then I put the same amount back. Well, if you think about it, when some squares are removed, and then the same number of squares are put back, well, what do you end up with? You end up with the same number you started with. So when you take them away and then put them back, you end up with the same number you started with. So that's called something we like to call the identity property. When you take something away and you put it back in, well, you end up kind of with the same number you started with. Nothing's really changed, except you just did kind of 2 different transactions. So we kind of look down here at number 2 now. It says build a tape diagram with 10 squares. I've done that already. You probably don't have this on your paper. So if you need to, pause it and go ahead and add it in. You should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I have 1 too many. So let's get rid of it. There's my 10 squares. So let's go through some steps kind of to show us how this kind of top part will work. It says, remove 6 squares. Write an expression that represents the tape the tape diagram. Well, I'm not going to remove them. I'm going to kind of circle them. So if I take 6 squares, 1, 2, 3, 4, 5, and 6. So I take these 6 squares. If I were to remove these out, okay, and I would use a pencil here because I'm going to be doing something with this. So please don't use a pen. If I was to write an expression for this, well, I started off with 10 squares, and then I removed 6 of them. Well, what operation would be going with this? Well, I started with 10, I subtracted, or I got rid of 6, I got rid of these 6, and now I'm only left with these 4. This is an expression. We wouldn't put equals 4, that would be an evaluation. So this is called an expression, just kind of what happened, what went on. We go down to B now. B says add 6 squares into the tape diagram after the original expression. After the original expression to alter, the original expression to represent the new tape diagram. So what they're saying is now instead of taking these away, we're going to put these six boxes or squares back in. That's why I told you not to use a pen, because we're going to erase this. We're going to bring these back. So now so now we're going to alter this. We're going to take this original one, so we're going to keep that. It needs to look exactly the same. This is the original expression, and we're going to alter it now. Well, what now happened? Well, instead of subtracting 6, we added 6 of them back. So the first step was we subtracted 6, and then we added 6 of them back. All right, so if you look at the next part C, it says evaluate the expression. Well, so let's go ahead and first rewrite what we have. The expression we have is 10. The first thing we did was we subtracted 6, or removed 6, and then we added 6 of them back, or put 6 of them back in. Well, what happened? Well, if we went through this, we kind of did this first part, we went this direction. That would give us 4, right? And then we added 6 of them, and this would give us 10. And of course, we started off, or we ended up with the original. Well, why does that work? Well, if we kind of rewrite it again, kind of do this twice, we kind of look at this, we look at what's going on, and we should notice something. We should notice something about these two numbers. This is a -6, and this is a +6. Well, what are these called? We talked about this quite a bit. These are, hopefully you remember, starts with an O. These are called opposites. Since these are opposite situations, this is a -6, taking 6 away and then giving 6 back. These really cancel each other out, and all of this gives us is 10. Okay, so all this represents, or this evaluation, is down to 10 because of these opposites here. So if we look at number 3 down here, it says write an equation using variables. So we're going to kind of take out the numbers and put in letters. Remember, variables are just simply letters that represent numbers. To represent the identities, was demonstrated in the tape diagram. So instead of having 10 and 6s, now we're going to use variables. Well, you could use any letters you want to. I'm going to use W. Well, if I start off with W, kind of any kind of number here, remember W just simply represents a number, and I take something away, so let's go ahead and call that X. If I take any kind of number away, and then go ahead and add that number right back, I add X back to it, that's going to equal or come up with the original, the W. So this is called using variables to represent a situation. If I start off with something, anything, and I subtract something from it, and I add the same something back to it, I end up with the original part. So there you go. So if I start off with W and I minus X from it and I add X back, it gives me the original, or gives me what I start with. Now you can plug in any numbers you want. W's have to be the same and X's have to be the same, and this will always be true. All right, so go ahead and stop the video. Go ahead and move on to the next examples. We're going to go through some numerical examples. They kind of hopefully go over this example again. All right, students, so now we're going to take what we learned from last video and we're going to kind of put it into practice now. So it's use your knowledge of identities, fill in each of the blanks. So we're going to fill in all these blanks with the proper number. So if we look at this, it says 4 plus 5 minus something has to equal 4. Well, here's the starting with 4. We added 5. What would I have to subtract to get back to 4? Well, hopefully you think about this. We would have to subtract 5. We'd have to get rid of this 5 right here to come back to this original number. So there you go. Just filling in the blank. Look at the next one. It says 25 minus something plus 10 has to equal 25 again. Well, what would we subtract if we're adding 10? Well, we would subtract that 10 to come back to the original. All right, so I want you to go ahead. I want you to pause the video. I want you to try C and D on your own. Come back, and I'll give you what the answers should be. All right, welcome back. Hopefully you came up with 45 for C, because these two numbers are exactly the same, or opposites, I should say. One's positive 60, one's negative. So that means 45 is the answer. That the original had to be 45. And same thing down here. If we have 56 and then we subtract 20 and add 20, well, we're going to end up with 56 again. All right, so there we go. That's kind of taking what the identity property and putting it into practice. All right, let's go ahead and kind of look at it again. Now we're going to kind of take the same knowledge or same understanding, but now we're going to use variables. Well, nothing really should change, except now instead of putting numbers in, we're going to put letters. So once again, we're going to do the first two together, then we'll have you do the last two on your own. So here it says A plus B minus blank equals A. Well, whatever A is, that's what it needs to come back to. If I add B, that means I have to subtract B, whatever number that represents, to get back to the original A, since these have to be the same. All right. So if we look at B now, it says C minus D plus D. Once again, we look here, these are opposites of each other. These will go away, or these cancel each other out, and we're left with C. So there we go. All right, so try C and D on your own. Pause the video, come back, and see what the answer should be. All right, hopefully for C you came up with F. If you look at this, E is here. If I add F to it and then subtract F again, if I subtract the same thing, I come back to the original. For this one, hopefully you came up with G. If I start off with G and then subtract H, add H, I come back to the original G. So there you go. That's what the identity property is. And that's how we use addition and subtraction to to show that property. So go ahead and stop the video and go ahead and move on to the problems of the day.